So let's do the integral of x over the square root of 3x plus 4. We have a square root term with a linear term on the inside, so let's just substitute u equals 3x plus 4, just to make sure that the term inside the square root is a single u term. If we do that substitution, then du would equal 3, which means before we do the substitution, let's just take out a constant of 1 over 3 outside the integral to rewrite this as 1 over 3 times the integral of 3x over the square root of 3x plus 4 dx, just so that we have a constant factor of 3 in the numerator. So we can go ahead with the substitution now. If we let u equal 3x plus 4, then du equals 3 dx, and we also have an x term in the numerator, so we have to rewrite that in terms of u. Since u equals 3x plus 4, if we subtract 4 on both sides, we get 3x equals u minus 4, and if we divide 3 on both sides, we get u equals 1 over 3 times parentheses u minus 4. If we substitute all of this into the integral, the square root of 3x plus 4 in the denominator becomes the square root of u, the 3 dx becomes du, and x becomes 1 over 3 times parentheses u minus 4. So the entire expression becomes 1 over 3 times the integral of 1 over 3 times parentheses u minus 4, all divided by the square root of u du. If we bring out the factor of 1 over 3 from the numerator outside the integral, this becomes 1 over 9 times the integral of u minus 4 over the square root of u du, and if we distribute the division of the square root of u in the denominator, this becomes 1 over 9 times the integral of square root of u, since u divided by the square root of u is just the square root of u, minus 4 over the square root of u du. If we rewrite this with fractional exponents, the integrand becomes u to the 1 over 2 minus 4u to the negative 1 over 2, and we can integrate each term separately with the reverse power rule. The integral of u to the 1 over 2 is 2 over 3 times u to the 3 over 2, and the integral of negative 4u to the power of negative 1/2 is negative 4 times 2u to the 1/2 by raising each exponent by 1 and dividing by the new exponent as a constant factor for each term. And all of this is multiplied by the constant of 1 over 9 because we had a factor of 1 over 9 outside the integral. And we also have to add the constant c. If we expand the expression, 1 over 9 times 2 over 3u to the 3 over 2 is just equal to 2 over 27u to the 3 over 2. And for the second term in the parentheses, 1 over 9 times negative 4 times 2 is equal to negative 8 over 9, and the u to the 1/2 stays the same. So the second term is just negative 8 over 9u to the 1 over 2, and we have to add the constant of integration c. We can rewrite the u to the 1 over 2 as the square root of u, so the second term becomes negative 8 over 9 square root of u, and the plus c stays the same. We originally substituted u equals 3x plus 4, so if we substitute that back in for the u, the final answer is just 2 over 27 times parentheses 3x plus 4, all raised to the power of 3 over 2, minus 8 over 9 times the square root of 3x plus 4 plus c.